Welcome to this webinar. Today we will cover two main topics. One is observability. I will take care of this one. Then Luca will talk about how to monitor large networks, especially if you want to take a look also at routing, BGP paths, etc. So let's start with the first topic, which is observability. Let's start with the limitation of traditional top monitoring. So usually when you use a traffic monitoring application, including ntopng, you look at time series, you usually see that the time series have a resolution which is like 5 minutes, 10 minutes, 15 minutes in some cases. But let's say best case, it's 1 minute usually. And this doesn't help much when you are running the tool for observability, where we want to see, for instance, microbursts, where you want to see congestion, which is really short. So like you have peaks, which are congesting your interfaces on your switch, for instance. And why this doesn't help? Because data is averaged across there's a lot in the time series, which is again 5-10 minutes. So you get an average. So if you get a peak which is 1 gigabit per second, but you are computing an average on 5 minutes, 10 minutes, you see traffic like at 10 megabit, 100 megabit, but you don't see the peak at 1 gigabit, for instance. So this is the problem. Another limitation that you usually have is that time series are defined by developers while designing the software. So while implementing the software. So if you have, if you want to have a metric which is, I don't know, the out of order packets for TCP for a host, you have to design it. I think when you implement the software, and that's it. So you get it. But if you need a new metric when you are troubleshooting, where you are analyzing the traffic, that's too late because you don't have the data. So you don't know in advance usually what you need. So for those reasons, we decided to extend our tools, ntopng and nProbe, in order to be more observability oriented. So what we decided to do is to, first of all, export high resolution counters. So go under minute. So that means that by default, in the current implementation that we just introduced, we are generating counters every 15 seconds, which is enough. It doesn't introduce too much overhead, so it's a good trade-off, let's say. And those counters are exported for every single flow. So this means that you have two things. You have precise time series with high resolution, so 15 seconds slots. At the same time, the flow is your observability signal. This means that you can build any time series on top of the raw data, because if you want a time series, for instance, with the traffic for a client host towards a destination host at a specific port, you can build that because you have data in raw flows. So this open to new use cases. So the ability to, just to mention a few examples, the ability to detect spikes, which are usually not visible when you get an average, the ability to correlate spikes with application slowdowns, because you have visibility really at high resolution. And also the ability to plan your network capacity to see if, for instance, your traffic is exceeding 1 gigabit, but your switch has 100 megabit ports. It's time probably to upgrade the switch. Those things are not visible with standard time series. So in order to implement this, we extended nProbe to produce high-resolution counters. Those counters by default are exported every, so not exported, we compute the counters every 15 seconds and store them into every single flow, which is exported to ntopng, for instance. And of course, we had to introduce the information elements to be able to export those counters. For instance, high-resolution dest-to-source bytes and high-resolution source-to-dest bytes. Those are like arrays containing counters with 15 seconds resolution, which are exported with the flow. So let's take a look at the data pipeline. So we have our network, which is providing a copy of the traffic through a mirror port. Then we have nProbe, which is analyzing this traffic, computing flows, and adding high-resolution counters to the flows. Those flows are exported to ntopng, which is consolidating this data in order to simplify the queries on the time series, and then you get the high-resolution time series. As of today, we decided to put those time series on ClickHouse because that's where we have the raw flows. And we will see that we can query this data from ntopng itself or external tools like Grafana. So, for instance, on top of those time series, on top of those raw data, we are able to build any time series. Like, for instance, I want to see a traffic from one host to another one. I want to see a traffic towards an autonomous system. I want to see a traffic at the interface level. So I just discard all the 5 tuple and just sum all the bytes. Or at the application level, because it's part of the flow metadata, the country level, etc., etc. So this provides full flexibility. And this allow us to translate ntopng into an observability platform. So not just traffic monitoring like today, not just cybersecurity, but also full observability. So as I said, data is stored on ClickHouse. And this means that you can use the Grafana connector to extract this data, to use this data and draw charts at high resolution. I want to show you a demo rather than showing you slides. So I don't know if you are aware that in ntopng, so as I said, we are exporting data to ClickHouse, and if you go under settings, preferences, and time series, you can enable time series on ClickHouse. And here you also have the ability to download a sample dashboard for Grafana to visualize the data which is stored on ClickHouse. So I already downloaded the dashboard and imported in Grafana, and this is the dashboard. So here you can see all the traffic using the time series produced by ntopng. You can see the alerts, etc., etc. Now I also built not a real dashboard, but just a sample dashboard with a couple of charts to show you that you can see high resolution time series in Grafana. Let's go, for instance, to yesterday. Let's zoom a little bit. I don't know, let's look at the traffic around noon. Let's zoom more. As you can see here, there are spikes, right? Let me zoom out a little bit. So this is, let me zoom out. Okay, so this is evidence, it's a big spike, and that's fine. But as you can see here, there is also a small spike around 12, 13, 45 seconds. So we can see this because we have 15 seconds resolution. Now let's move to a standard chart in ntopng. I forgot to mention that in this case, in this sample dashboard, For instance, I'm building this time series by extracting traffic from one specific IP address to another one on a specific port. So this is one example that you can build on top of raw counters. Or in this other case, we have traffic, all traffic divided by application. So you can see HTTP traffic, Emacs traffic, NetBIOS traffic, etc. But let's focus on this traffic produced by this host towards this other host. So if we take this IP address and we go in ntopng and we search for this IP address, for instance, I want to see the same time interval using standard time series. So it was yesterday 12:25. So let me go to yesterday 12 something. Okay, so we have seen that we had a spike, a small spike actually, but we can zoom in, of 35 megabit per second at 12, 30, 45 seconds. Now, if you go at this chart at 12, 30, 45 seconds, we see that there is nothing because this resolution is too low and we compute an average and you lose it. So you see like 2 megabits in this case. So this is why high resolution time series are so important. Okay, so in essence, we wanted to evolve, let's say, ntopng in a real observability platform. This will help us both with anomaly detection, automated incident detection, because it's providing data which is more accurate. This will allow us to improve the resolution of the charts and the flexibility, as we've seen, because we can build any chart on request dynamically without having to decide when we develop ntopng what is the chart that we want to, the metric that we want to draw. And this will also help us with the AI-based analysis. We will see in the next webinar also what we have done with AI. And having this data on ClickHouse also help us exporting this data to other platforms. We have seen today Grafana as an example. Okay, so thank you very much. Luca will talk now about monitoring large networks.
Yes, can you check if there are questions? You want to take questions or at the end?
Yeah, I don't see questions in the chat, but yeah, let's take them at the end.
Okay, well, let me take over the screen then.
Yes, sure.
Okay, now let's jump to a different topic, monitoring large networks. For a very long time at ntop, we have focused on packets. And then we have collected flows from routers and switches, SFlow, IPFix, NetFlow. But we have never really investigated the monitoring from a perspective of a large corporation with many branches, an ISP, a service provider. And the idea is that it's now time to do that. So this is the presentation today. In essence, I want to explain the challenges in monitoring large networks, where you have various branches that need to be observed, need to be monitored. Today we're introducing open source AS traffic observability. I will show you that. The code today I'm going to show you is open source. It's available on GitHub. I want to present the integration we have done with two routing protocols. One is BGP, for the gateway protocol, and the other one is BMP. That is in essence the monitoring part of BGP. So it's the equivalent, but just for monitoring, PGP monitoring protocol, it means. I want to show you how you can monitor traffic, not just from the IP standpoint, but also from the autonomous system standpoint, without costly subscription to cloud-based products. Okay, this is very important because those tools, unfortunately, are very expensive, and many people are coming to us saying, "Hey, look, I try to convince the ntop team to create something for us because we need to observe traffic, but we have different needs. Okay, with respect to people that can observe packets. Why this? Because in your network, so in the network you are monitoring, the network you are owning, okay, you can do the packet inspection. You can analyze the traffic. You can say, okay, this IP is doing something wrong. Let me go investigate this computer because probably there is some malware. There is something that I did not expect. Okay, there is something wrong. But this is a privilege. So in the sense that you can do that on the traffic you own or that belongs to you, let's say. But in other cases, you have different scenarios. They can be mixed or they can be totally different. Let's make an example. You're a network operator. You're a service provider. Your goal is not to judge what people are doing. Your goal is to make sure that the infrastructure is healthy, everything is running, the traffic that you expect to see is really passing where you expect it to pass. That's it, end of the story. You should not go down at the IP level. That's the problem. Okay. And of course, this is an example. The other example that is probably more realistic is that you have a network, you have a large network, and a portion of the network is your network. So let's say you're a network operator. So you have some computers, some subnets that contain servers you use, you control, and you want to see traffic of those. For the rest of the traffic, you want to see flows, okay? Because flows are, let's say, more aggregated. And so I don't know where you are. I don't know what you're doing in life, but it might be that you are a packet company, you're a flow company, you're in the middle. So in essence, now we want to look at the traffic from a large perspective. So when you have a large network. Now, what's inside the flow? Okay, either SFlow, NetFlow, IPFix, more or less they're similar, but here we are mostly focusing on NetFlow and IPFix. Inside a flow, you have information about the exporter. So in essence, the device that is exporting this traffic, and you also know the interface. So you say, this traffic has arrived at me on interface 1, has been routed towards a certain destination, and it has been egressed on interface 2. Okay? And you have information about routing and peering. So for instance, you have the adjacency information. So you have the AS from which you have received the traffic, the AS towards which you are sending the traffic. And of course, you have the remote ASs that this we can compute using MaxMine and other type of tools. So in essence, we have metadata, okay? This information is not available in packets. This is something very important to tell you. In essence, when you have a packet, you only have the content of the data, but you don't have the, let's say, the metadata around it. You don't have the annotation. You don't know this packet from what portion of the network has passed through, and you don't know from which interface has been received. So with flows emitted by a network device, by a router, for instance, you have this type of information, and we need to exploit it. Now, what we usually do here in this case is that we have nProbe that is collecting flows from various types of devices using the protocols I mentioned, and then nProbe exports this flow to ntopng. In this case, we export information.
Sorry, Luca.
Yes.
Sorry, Luca. We still see the first slide, so we don't see. Yeah, now it's working.
So let me. So you didn't see the previous slides then?
No. We just see we have seen until now the first slide only.
Oh, sorry, guys. So this was the previous slide. Let me keep it this size. Okay. So in essence, here we have the flows. Okay, the flows are exported by a router. Okay, they are received by nProbe. nProbe is normalizing them and then delivering them to ntopng. We have DPI here, but DPI in this case is a lightweight DPI because we don't have the packet, so the P of DPI doesn't hold. And here we are able to, let's say, monitor traffic and do DPI based on the IP addresses on ports. So in essence, it's a guess, okay? It's not a real DPI. But for many protocols, what we call protocols in NDPI, we have good information. So for instance, Office 365, WhatsApp, Meta, Facebook, this type of information is coming directly from the companies that are reporting them to us. So this information is reliable, but let's say it's less accurate than the real DPI. However, it's enough, because if you want to say, if you want to answer the question how much traffic is going to Google Cloud, or how much traffic is going to Office 365, you can do it. Okay, so it's lightweight DPI. Now, the problem of a large network is that sometimes you have duplication of flows. This is because you can have multiple observation points. You can decide to monitor the traffic at the edge, in the center, environment. So the topology is really important. That is not a rule of thumb. So in essence, every network is different. Okay. So in this case, let's have a look at this picture. So in this case, if you deploy, a probe, let's say if you enable NetFlow at the edge, okay, you don't have theoretically any duplication. Okay, but if you enable on multiple sites, or if you have something in the middle, you might have duplication. What is a duplication? A duplicated flow is a flow with the same 5 tuple, so protocol, IP, and port source and destination that are the same, that have been observed by different exporters. So it means that if you have a larger network, so you see the same 5 tuple on the same time period, okay, so this is very important, that has been observed by 2 entities. Now, unless you do the duplication, you're counting the traffic, one time, multiple times, depends on the topology, depends also on the network, because sometimes you have a duplication that is static in the sense that it's built into the network because the network has been built in a certain way, or you have a duplication that is dynamic because some network links are failing, so you use the backup, and in this case you have duplication. So there is a problem. So we don't know statically, how many times the flow has been duplicated. So what we can see here in this example, so we have added a new column inside the info. So in this case, where we see how many times, so we have seen a certain flow. As you can see, sometimes you see once, sometimes you see 5 times, sometimes you see 3. It depends. Okay, depends on the network. Now, is it good or bad duplication? I don't know. I cannot really answer this question. It is good in the sense that you can see a trajectory of a flow inside your network, because if you're observing the traffic multiple times, you can see inside the ntopng now we are reporting when the flow has been observed, and if it was a return path, so it means if it was a unidirectional flow from destination to source, okay, or if it was a forward flow, like the first one, the fourth, and the fifth, okay. And you can see here the interfaces. So you know exactly how the traffic pass inside your network. But this information can be partial, because it might be that a certain flow, okay, cannot be observed completely. It depends on the way you have implemented the exporters, okay. But in ntopng, so we have added a counter and the interface that allows you to see, okay, how much traffic is duplicated. So in this case, in this specific network, so we see the traffic that it was doubled, in essence, 49.9. So in essence, we are seeing the same traffic twice. But of the new announcement that we have introduced, okay, ntopng is accounting once, okay? So the counters should be correct, okay, regardless of the number of exporters that are seeing the same traffic. You can enable the duplication also in nProbe. Okay, in ntopng is automatic. It displays this only if you have duplicated flows. In nProbe is not automatic. You can enable it through this command line. Now, the difference between the two is the following: that in nProbe you can deduplicate only at the nProbe level. So it means that if nProbe is collecting traffic from 2 routers, okay, it can deduplicate from these 2 routers. But if you have multiple nProbes, because your network is very large, so you have a lot of traffic, a lot of data to monitor, the duplication happens only at nProbe level, but not across multiple nProbes, because each nProbe is an island. Okay, so that's why we have left enabled by default the duplication in ntopng anyway. Okay, so most of you probably they have never experienced duplication because you're probably enabling it only on the gateway, and that's it. But in case you want to enable multiple devices, now we have this ability, okay, the ability to monitor the traffic and duplicate it automatically inside both ntopng and nProbe. So as a rule of thumb, ntopng will deduplicate it anyway. If you want, you can deduplicate in nProbe, but this can be a partial deduplication, like I've said, because if you have multiple nProbes, not all the nProbes are able to see the whole amount of traffic. So in essence, depending on your use case, you will decide what to enable. Okay, what is your best practice? Okay, there is not a single solution for most of you, even though most of you will probably enable just NetFlow at the edge. So when the traffic enters or leaves your network, not south traffic in essence, and that's enough. Okay, so that's very important. But if you leave duplication on, so if you have multiple probes supporting the same traffic, you can see the trajectory of a certain flow inside your network. Now, the problem is that if you have a large exporters, if you have routers with many interfaces that are exporting data and not from just the management interface, you have multiple IP addresses. Okay, in previous version of ntopng, matching didn't work, but in this new version, so with the latest enhancement, we are polling additional MIBs from SNMP. So we are polling the IP addresses of the interfaces, IPv4, IPv6, depending. There are various MIBs depending if your device is using the old MIBs or the new MIBs. So in essence, we are polling all of them. So we are able to match IPv4 and IPv6 addresses with a certain exporter. Let me rephrase. Whenever a flow is received, like in this example, okay, so the IP address that you can see here is mapped to a physical exporter, okay? This if you have enabled SNMP, of course. If you have enabled SNMP, we have polled all the interfaces of the routers, okay? And thanks to this, we are able to correlate them to the router, to the management interface, let's say, okay? This is very important. Now, nProbe, therefore, can collect flows from one exporter, so from one router, let's say, or from many routers, okay? So in this case, we have enhanced the UI, and as you can see here, we are depicting on this Sankey, okay, the exporters. The size of the line means how much traffic a certain exporter has received, okay? And we are also depicting here the interfaces that are being used by the exporters, okay? So in essence, here we are trying to match the exported traffic, the amount of traffic seen by each exporter with the interface, okay, they're using for exporting the traffic to ntopng. So in essence, we have added this one, okay, and we have managed to put here the real IP address of the device, okay. That is very important because it's really helping us. Once you've done this, we have spent a little bit of time on the next hop. So whenever we receive a traffic, okay, a traffic flow, many times the next hop is set. So again, it depends on the way you export the flow, but if the next hop is set, so we are able to see the traffic that from a certain exporter that is sending us the flow, okay, what is the next hop for this flow, okay? So we are able now to see how much traffic is going from a certain destination to another destination, or in this case, from a certain exporter to another exporter, okay? So again, this chord chart is meaningful if you are able to see traffic multiple times. Otherwise, you will see, that the traffic is going from your router to the internet. Okay, the next hop does not belong to your organization. But depending on your use case, you can see this information. Okay, so if you are able to see the traffic, so this is very important because if you have a large network, let's say the traffic going from Munich to Berlin or Berlin to Düsseldorf, you can see it depicted here, and you can understand the amount of traffic. You can see the major directions of the traffic inside your network, okay? Because we are not thinking anymore, okay, just in terms of IP addresses, but we are also thinking in terms of exporters and interfaces. In addition to this, we have introduced a new concept called site. So a site, basically, it's a network, okay, that belongs to a certain physical location, okay? In this example, I put a few towns in Italy, but it doesn't matter. So you can create a site, you click here on the plus. This page is inside the network. So you go interface, networks, and inside the networks, you will see a new entry here for sites. When you click on the plus, you define a site. You put a name, a symbolic name, okay? And you can put a description and a location. A location means that you can click on the map, you can have the physical location of the traffic, because in the future we want to make a map based on that. So this is a physical location, okay? And then once you have set the site, you can bind your network to a site, meaning that when you start ntopng with -m, okay, so you're familiar with that, we specify your networks, okay, your local networks, the networks of your organization. Now, with the GUI, you can say this network is in this town, this network is in another town, this network is yet in another town, okay? And this is very important because if you go on the report dashboard, so if you go to ntopng, the report on the left sidebar at the top, there is this entry, you can see the network traffic divided according to a site. Say, let me see the traffic that is observed in Munich, okay? Or you can go outside, so zoom out, you can say, let me see how much traffic going from Munich to Düsseldorf, okay? And each site can have multiple networks. I mean, a certain site cannot have just a /24, let's say. We can have multiple networks that we group together and we depict, okay? So this is reported inside the dashboard. And you can also see now a new type of chord chart. How much traffic is going from one town to another town. As you can see here, there's a percentage, okay? And the percentage here is computed based on the site. So you can see the standard, percentage based, on IP addresses, or the percentage based on sites. Okay, how much traffic is going from site A to site B? Okay, and if you want to optimize, if you want to see a view of the traffic, not from the IP level, so very low level, but to the upper level, you can really understand how this traffic is moving. Now, because traffic is exported by routers, okay, by exporters, this traffic, like I've said, has an interface in and interface out, okay? We have added the ability of setting the role of a certain interface in your network. We have added a new entry, as you can see, port role inside the SNMP, where you can specify through a drop-down menu what is the nature of this interface. Let's say, is this a transit interface? Is this an internal network? Is a peering interface? Because this matters. This matters in large network. It doesn't matter in a company, because probably when you have a company, most of your traffic will be internal traffic, or if it goes to the internet, it will go through a provider to be, let's say, transit traffic. So you will pay, uplink X or uplink Y, and that's it. So you're playing probably this traffic flat. But if you're a network operator, it's very important to distinguish this. But even if you're not a network operator, if you are a large company, let's say an insurance company, a bank, an organization that is across, a large network, you can specify here the interface type, okay? And we can create the reports based on that, okay? Let me show you. So when you have a flow here, inside the flow, we write here the origin of the flow. So why we have received this flow? What is the way that was used to receive this flow? For instance, this flow was received through an internet exchange, okay? So it means that we have a flow has been observed by by several exporters, and one of them is, as you can see, was an internet exchange. So it means that this traffic was received through a certain location, okay, and we know exactly where this traffic is coming from, okay. So here we have duplicated flows simply because here we see the traffic multiple times. But if you only enable net flow, like I suggest, at the edge of your network, so the traffic that is entering or leaving your network, this will be very simple, will not polluted by multiple entries, okay? ntopng detects that and labels it, internet exchange. Now, if you have, like I said, duplicated flows, okay, from the traffic standpoint, we account the traffic once, but from the graphical standpoint, we can also show you how is the traffic moving inside your network, and we can label not just the exporter IP, but we can label also the site. Okay, we can tell you, this traffic is arriving from town A, it's passed to town B, to town C, and then to the internet. Okay, so this is very important, and we can depict the forward path, because the one with the solid line, or the dotted line here is the return path. But again, this picture might be incomplete because it depends on the exporters you are enabling. Okay, it might be that you see the whole traffic, or you see only a portion of the traffic. Again, if you have a simple network, or if you don't want to go into this burden, simply put enable the exporter at the edge of the network and don't enable too many of them. Now, once you have labeled the interface, you can see here inside the traffic here, the network interface. You're familiar with this page, right? So you go inside the network interface, you click on the icon chart, you see the charts. here now in the network interface, you can see how much traffic is going through certain type of network interfaces. You see how much traffic is going through my transit, how much traffic is going to my internet exchange or through peering. Okay, this is very important. So you understand, because some type of traffic are free for you. You pay a flat fee, beginning of the year, end of the story. But certain other type of traffic are not flat. So it means, for instance, on a transit, in some cases you pay a certain fee up to a certain speed, and above a certain speed you pay another fee, or you pay on top of the speed you have decided to pay for. So again, it's a new visibility, let's say. So here we are not talking about autonomous system, we are not talking about destination, we are talking about how much the traffic is costing you based on the interface type. And of course, you want to have the traffic as much as possible on your network. And for every interface here, so if you go to SNMP, this is an SNMP device, we put not just the usage. So we have discussed this some time ago, where it's possible to enable ntopng to trigger you an alert when the usage of a certain interface exceeds a certain threshold. But we can also see now the interface role. And here, if you go on the top right side, you can see the ingress or egress flows. You can say, on this specific interface, what traffic is currently passing, okay, now in this interface? What's going on in this interface? If you see a spike, say, who is responsible for let's say, the transit peer in Düsseldorf towards the internet, okay? It's now possible to do that. So this has been an enhancement we have introduced to give people visibility of their network. Now, because of that, so we have also extended the flow page. You have been familiar with the flow page, live flow page, I believe, right? So now you can see here the exporter, the destination S, and you can see also the interface role. Show me all the peering traffic, or show me all the traffic from this exporter to an interface, to a specific interface, or to a peering interface. So just to understand, okay? So in essence, we have not recreated anything. We have just extended the existing interface. And of course, if you have a large network, you probably have an autonomous system number, right? And in some cases, if you're a service provider, or if you are a large company, you have customers. So you can see, these are my customers, this is my ASN, and these are remote ASN that I don't own, okay, but are relevant for me. So for instance, Google, Facebook, Meta, Netflix, these guys, right, that you want to control. And because of that, we can also now show you exactly the traffic from the autonomous system standpoint. So if you go inside the network sidebar, so left sidebar, interface, autonomous systems, now we have a new page that allows you to see the top ASN, okay? The traffic here is divided according to send and destination as usual. And you can see here also the traffic divided per role. So you say, for instance, in this case, Facebook, see, most of the traffic, how is delivered to me, through a transit, to a peering, through other type of interfaces. And here you can see the autonomous systems over time, okay? You can see not just all the ASN, but also my customer ASN. So it's, for instance, what are my customers accessing the internet for, okay? So what is the meaning? Because in some cases, if they're accessing links that are paid per use, but I don't get enough money from these guys, so basically I am losing money, right? So this is very important, because it allows you now to have this type of visibility. And also you have another type of visibility. You have the ASN visibility. So you can say, given an ASN, so that you can select here on the previous page, on the actions, you can click on an ASN, right? You can see a certain ASN, what type of traffic has received, what type of traffic has sent. And for every ASN here, there is a drop-down menu here. You can see the traffic according to the interface. So I say most of the traffic from this AS has been received by this router, and very little from this router, and even much less from this router. And when this ASN has sent data, okay, it has used most of the time this router. And this is a chart. So if you click here on the interface on the exporter, you can see the traffic and filter the traffic according to the exporter or to the interface, okay, for every autonomous system. And we have a similar view, but based on ASN. So let's say, who's using Facebook, okay? Most of the traffic is received by these guys. This is the traffic that is sent out. Exactly the same view, but here in interface, here is ASN view. And of course, you can have a certain breakdown per customers. So if you have a larger operator, you say, who's using, let's say, Amazon, is an example, divided according to my customer. You can see, the customers are using the traffic. So you can also split the traffic according to the usage if you are a big company. Of course, if you are a single company, a huge company, but no sub customers, you will see only one customer. Now, we have also added a new feature called ASN mode. In ASN mode that you can enable here in the preferences, you go preferences, ASN mode, you can enable it only if you have a 0nq interface. In ASN mode, in essence, we restrict the view. So we try to hide IP addresses, as much as possible. They are there, but they are hidden, okay, unless you really drill down. And this is because if you're a network operator, you should not see too much of your network, but you should have an idea of what is happening. Again, this is in and out, so you can decide at any time to turn it down or off. And there is also the ability of masking IP addresses at nProbe level. So nProbe is collecting flows and sending them to ntopng. In this case, you can enable ASN mode here, --ASN mode. And the difference here is that if you enable ASN mode inside nProbe, so we mask the last byte of the IP address. So we try to somehow to hide certain information, so not to be able to find the specific IP. Of course, you can find the specific network, but not the specific IP. So this is just for privacy concern. In case you are interested, it's a new option that we have added to nProbe. You can enable or leave it as it is today. In addition to that, we have decided to also to have a look at routing. Okay, so in this case, we have created one daemon called BGP server. So this one daemon that is part of the nProbe package. This daemon is totally free if you have nProbe Enterprise. Is part of it. The probe comes, with this new package, and the server is doing this. So in essence, is opening based on the configuration. It's opening a BGP session or BMP session or multiple BGP sessions with your routers. So you can use it to collect your data. Okay. By design, we have coded everything from scratch. At the end of the presentation, I will show you the URL. So we have coded everything from scratch. So there is no chance, it's impossible that the server is sending a BGP update to your router, okay? Simply because we have not put this code into it, okay? So we want it to be totally transparent. So at the moment, it's able to receive the whole internet table, okay? And from multiple routers, of course, and to show you what's happening and to receive the BGP updates using BGP or BMP, okay? It's up to you. It's just a configuration option. If you have a BGP, you can use it. Better if you have BMP because it's the monitoring protocol designed for it, but we can do everything. So in essence, this BGP server acts like a Redis server because Redis is a very popular product, but this is not the main problem. The main thing is that, Redis is a protocol. It's a known protocol called line noise. So this protocol is very simple. So you can use the standard Redis client to attach to it and to extract your data. So for example, tell me the best path for, or give me some information, I will show you. And this BGP server has also the ability of being configured with a list of prefixes, okay, that you want to observe, okay? So let's say if you have a special, prefixes that are relevant for you, you want to receive updates from them and to display them in ntopng to see what's happening to those prefixes, okay? So in addition to the standard configuration, you have the ability of specifying that, okay? As you can see, it's a simple tool. Now, this tool has been integrated in our tools. So in essence, if you start a BGP server and you can talk with nProbe, so nProbe, whenever receives one flows, okay? So one flow, of course, has, interface in, interface out, export, and blah, blah, blah. But you can also extend it with routing information, routing coming from your network. So you can put the whole IS path, the communities, anything I will show you, okay? And this BGP server through the Redis protocol can be queried by ntopng or by anything you want, okay? So I will show you that in a second. This means that when a flow is received with BGP, okay, BGP is an optional component. You don't have to use it, okay, unless you can start it. But in some network, this is not possible. So let's say if you start it, nProbe before delivering the flow to ntopng will extend it. We have added here, a BGP, subpage. Okay, you can see the routing. Okay, the routing that we have learned from the BGP server. Okay, so this is your information. Okay, so in every network we see the different information according, okay, to your network. So basically, it's basically designed for you. And we have also integrated inside ntopng a looking glass, meaning that for every IP you want to put or prefix, we can look into the BGP server and see what are the options that you have received and what is the best option, okay, according to the BGP protocol. So this means that you can see all the various options for a certain destination. So for instance, this is Cloudflare popular 1111, okay? You can see local prefixes, next stop, anything. And we can check here RPKI. So this is a validation of the route. So everything is done by ntopng through the BGP looking glass we have implemented. You can receive, of course, alerts, okay? When a certain traffic for an ASN exceeds a certain threshold, okay? You can decide how often to do that. And also you can receive an alert when the ES ranking has changed. So for instance, we changed it from this ranking to this ranking. So meaning that the first 5, okay, router interfaces and export interfaces that are sending a certain traffic have changed. For some destinations are not very important because over time, the service provider is changing the way data is delivered. For others, it's very important because you expect to receive, let's say, Netflix always from a certain location. And if this changes, it's a problem for you, okay? Just to complete this presentation, the code we have coded is part of the dev branch, okay? It's available today. So if you update the package, you can see everything I've shown you today without any additional cost. Okay, if you have nProbe M or above, the BGP server comes with it. There is nothing else you can add. So if you have a version without ClickHouse information, so the basic ntopng, the community or the pro, you will see only real-time data. If you have Enterprise M with ClickHouse on up, you can see historical data. You can go back in time. You can see, so for instance, the BGP information with the flows, historically, so you can check it. Of course, everything is stored inside the ClickHouse. So the BGP information I'm showing you is part of the historical flows. So if you have a flow from yesterday, you want to compare it to today's flow, you can do it. That's possible. It's available in only ntopng versions. Of course, the current code is inside dev. Okay, we're still polishing it. We have first adopters that are testing it. I would like you to test it if you're interested. Again, the BGP component is not mandatory, so you can enable if possible. Otherwise, everything else represented is there. You can see the traffic. And if you have any comments, let us know because it's very valuable for us. As future work items, we'll be introducing AI. I'll talk that in a second for assisting us to understand the data. Okay. So for instance, we're making experiments since a couple of years at least, and soon we'll talk about that. We plan to send additional alerts to extend our implementations for instance, detecting DDoS or detecting spikes that are not due to a DDoS. So for instance, when people are watching soccer matches, you would see a strong increase of the traffic, but that is not a DDoS because in essence, you're sending or receiving data always towards the same destinations. We want to add some intelligence, okay, for those that are operators that are paying traffic according to transit peering or to those concepts to give you an idea where you can optimize your bandwidth. And we're open to new ideas that you might have. Just to finish, like I've said, it's a long time we're playing with AI. We didn't say much about that because we thought that the market was not really mature, okay? So, but now we have created something that we believe is time to show you. So soon we'll announce this new webinar that it's in about 2 to 3 weeks. So it will be June 9th. As you can see here, you will see an AI chatbot, but it's much more than that. Okay, so I don't want to disclose too much information. You know that ntop, we have always decided that data sovereignty matters. So if you want to use cloud solutions, you can use cloud solutions. But if you want to stay on-prem, we allow you to stay on-prem. We don't push you to the cloud. We don't push your data to people that can misuse your information. So I will soon send this invite. I hope to see you online. And we believe that this one can be complemented with what I'm showing today. Yesterday, we have just introduced the MCP server. So it means that you can use, for instance, Cloud Code or Codex with ntopng, and you can ask complicated questions and ntopng can answer for you, okay? This will be the next step that will happen soon. That's all at the end of my presentation. Here you will see the new components that we have created for BGP, from top of which we have created the BGP server. I want to thank personally these 3 friends that allowed us to do the initial test on the network. And I'm now open to your questions. And I hope that you can, find this valuable. And I would like to find other people interested in testing it or telling us, fix this, change that, because you are the experts, and for us it will be very valuable to hear from you. Thank you.